Hello guys, good evening. Have you guys tried the problem that I have given yesterday? I think Vishnu has sent me already. And Ramya, you too already sent. Okay, Ramya, let's don't waste time. At least you guys are present. I think I have seen your guys' solutions, Vishnu's and you, Ramya's, and then I found that you both have drawn ILD for vertical reaction at A is correctly.
Yes,
And vertical reaction at C, how it's gonna look like, do you think? Let's say if I apply unit displacement along the upward direction at C, then as you know, CB and CD it is a continuous, isn't it? As it is a continuous, they both should be continuous. Slope should be same. So what happens if you apply unit displacement? This is what the deflected shape that you will get it. And the slope here must be, if this is 3 meter and if this is 2 meter and if this is 3 meter, as it is unit displacement, the slope will be here 1 by 2. And the ordinate here will be total 5 meter length, 5 into 1 by 2. So we'll get it as a 2.5. Vishnu, I don't know why you have taken CD part in inclined way. Can you justify it? It seems like you might be in study hall, am I right? I think Ramya, how about you? Vertical reaction at C. Yeah. Ramya, can you please tell why CB is horizontal? I just want to know. Why CD will be horizontal? CB and CD both are continuous or not?
Yes, sir. Yes, sir.
If both are continuous at that joint, then what about the slope of this should be equal to the slope of this, isn't it?
Yes, sir. Yes, sir.
Then in that case, the right side part will also move along with the same slope.
Yes, sir. Yes, sir.
Did you understood where
Yes, sir.
where the mistake is? That's why wherever after drawing the diagram, you guys might check it. Like,
yes, sir.
I think Vishnu, it's clear for you also. Let me draw here reaction for A. If I draw the reaction for A, if I move it to the unit displacement 1, as it is a fixed support, the rotation will be 0, isn't it? If the rotation is 0, this remains in a horizontal. If this is horizontal, then what will happen? The part AB itself will move out, and then this will be your ILD for VA. And can you tell me what about this slope? This slope will be again, what about this magnitude? 1. And what about this slope? This is 1 by 2. And what about this slope? Total 3. 3 into 1 by 2 is how much? 3 by 2. Both of you, can you tell me, is both these diagrams are okay with you?
Yes, sir.
Right? Now let me give you a trick here. Like here, let us say, consider the same beam. Let us assume whatever may be the position of the unit load. Okay. According to the equilibrium condition, if you do summation of y is equal to 0, how much you should get it here? What about VA plus VC? Can I consider the both equal to 1? Whatever may be the position of the unit load. Total download load is equal to 1. So if you add those two values, the value will be equal to 1. In the same way, you understand in these two diagrams, if we add ILD at any point, ILD for A plus if you add at any point ILD for B, if you add they both, you should get 1. Can I write this equation or not? Based on the equilibrium equation.
Yes, sir.
At point A, if you consider, what is the ordinate of ILD for VA? 1. What is the ordinate of ILD for VA?
1.
1, isn't it? What about ordinate of ILD for VC?
That also
See
1.
this. If I'm talking about ILD for VC, see this color. 0.
Yes, sir. 0. Right.
So 1 plus 0, 1. Look at it, C. If you look at it, C, what is the ordinate for ILD of VA? Look at this color. What is the ordinate? Can I repeat what I said, or do you agree this equation first of all? I'm
Yes,
just
sir.
giving you furthermore additional equations so that whatever the equations or whatever the diagram that we have done just for the verification purpose only. So after drawing VA1, can I erase some of these things so that I can write it down easily?
Yes.
Do you guys agree that ILD for VA plus ILD for VC is equal to 1? Just like if you had summation of forces at any equal to 0, obviously, if unit load is acting on the system, then you can say, isn't it, VA plus VC should be equal to 1. That's what the same logic that I'm gonna apply here. Key, at any point, let us say at any point, it doesn't matter. Take the ordinate of ILD for VA, take the ordinate of ILD for VC and see whether they are gonna equal to 1 or not. If I talk about point A, what is the ordinate of ILD for VA at point A? I can look at this diagram, and what about the ordinate? 1. If I look at for ordinate of ILD for VC, from beyond this point it is 0. 1. If we see at point B, what is the ordinate for VA? ILD of VA at point B. Look at point B, see the two different colors. At point B, what is the ordinate of ILD of VA?
1.
1, right? And what about the ordinate of VC? See this color.
This is 0.
0, 1. Look at point C. What is the ordinate for VA?
VA equal to 1.
Ordinate for VA. 0.
0.
What is the ordinate for VC?
VC equal to 1.
Ordinate for
sir.
VC 1. That will be equal to 1. Let us look at joint D. What is the ILD for ordinate VA?
0.
VA, see where it has ended up. It
3
ended up
by
here.
3 by 2.
It is in the downward direction. If it is in the downward direction, minus 3 by 2. What about the ordinate for ILD of VA? Sorry, this I should write down here, isn't it? Minus 3 by 2. No, I did it correctly. What is the ILD for VC? Just a second, guys. My system got stuck. Yeah. What is the ordinate of ILD for VC? It is in the positive direction. Plus 2.5. If you add this, how much you will get it? Minus 3 by 2, 1.5. Minus 1.5 plus 2.5. How much?
1.
Are we getting whatever the point you consider? Are we getting 1 or not?
Yes, sir.
So this might be a check you can think of. If you can add those, both are getting 1, then your diagrams might be right. But I can't say. If any one of the diagram is wrong, you can't get 1, isn't it? So I'm just giving you a hint. Is it okay about these two diagrams? Are any doubt?
No, sir.
Let me know if you guys talk freely. It doesn't matter. Please, free to speak as much as possible, please. As we are going very slow.
Yeah, sir. Understood.
Yeah, right. Now let us draw the shear force diagrams. Which one can I draw first? Let's start with.
Sir, I have
Sure.
a small doubt, sir.
Yeah.
Sir, ILD for VC.
Yeah, VC.
Sir, the shear force
Yes,
part is a bit confusing, sir.
Sorry, ILD for VC.
ILD for VC in case if the
Ah.
support is hinged support instead fixed support, then how it will become the ILD, sir?
Where it is fixed support?
At the point A.
At point A
Instead,
instead of.
fixed support, if it is become hinged support, how it will become the ILD shape, sir?
If it is a hinged support, is it stable first of all? What is the
Not
determinant?
stable, not
Not
stable.
stable. Then how can we draw it? It itself not a stable structure, right?
Oh, okay, okay, sir.
Okay.
Okay, sir.
Then let us write down ILD for shear force right of point A. I think this you guys might have got it. Why? Because which support can I place to the right of A? Vertical shear hinge I can place. I can move this part to the upward. Take this as 1. If I simply move it, rotation will be 0 at point A. That's why this will be horizontal again. As you guys might have seen, this is what the diagram that you will get. This is the ILD for shear force to the right of A. Anybody have confusion in this diagram? I think everybody might have got it.
Yes, sir.
If you guys have any confusion in this, we'll discuss in. I think Ramya and even Vishnu, they both have done it correctly. So I think there is no doubt here. At least if there is no doubt, please confirm me. No. Let us talk about what about the other points that we have discussed? ILD for shear force to the
Left of C.
left of C. Now, if I apply ILD for to the left of C, then how it gonna look like? To the left of C, I will apply again a vertical shear hinge. Left side part, I will move it in the downward direction. As it is a hinge, I can say that this simply comes like this. And at C, it is it is a continuous member, or at C it is a joint. At joint C, two members are connected, CB and CD. As it is a joint at point C, it is a continuous joint. Then we know that slope of CB must be equal to the slope of CD. If I take CB only like this, we know that CB is rotating in a clockwise direction. That's fine. What about CD? Even if you look at CD, it is a horizontal direction. If you are not deflecting it, no. But CB you are rotating with clockwise. That's why member CD also you have to rotate it in clockwise. That's why rotate CD member is also in a clockwise direction. So that's why this is what the ILD for shear force to the left of C. I think Ramya, you have drawn this incorrectly. Let me check it where you have done. Yeah.
You said that we have to split the it will be in a horizontal direction.
It again, or even you can type it, no issue.
Yes.
What about other two? Priyadarshini and Andal?
Sir,
Yes.
sir,
By
actually,
introducing shear
Frank,
connection.
I didn't do so.
Okay, fine. By introducing vertical shear hinge, this is if we are using vertical shear hinge, obviously it will move in the vertical direction. How come it will move in the horizontal direction? there are two types of shear hinges. This is vertical shear hinge and this is horizontal shear hinge. You can see the direction of the rollers. If you see the roller direction, these are placed along the vertical direction. That's why if you place this type of hinge in between any joint, the members will move along the vertical direction. As you can see the rollers here, this is placed along the horizontal direction. That means the members move along horizontal direction. It's depend upon the direction of the roller that we will place. Did I clarify your doubt? Feel free to ask. Don't carry forward your doubt. Let me know. Do not carry forward. We are going very, very slow. It doesn't matter. Just let me know and please understand. That's it.
Sir, the thing is the D point is free hanging right now, sir.
Yeah.
Then it may come the horizontal zero slope in between C to D.
C to D, you mean to say that it can be in a horizontal direction, isn't it?
Yes, sir, zero slope because of overhang.
Look at the joint C. Once again, I'm talking, it should not disturb the continuity. If you see the joint C, how many members are connected at joint C? CB
Two
is
members,
connected,
sir.
CD is connected, right?
Yes,
If you
sir.
draw the deflected shape, I can say that the slope of CB must be equal to the slope of CD. If this condition is not satisfied, then sorry, that is not a continuous joint. It can be treated as a rigid joint. As like you, if you want to consider treat it horizontally, the slope of CD is 0, but the slope of CB considering in some value, but continuity is satisfied? No, in that case. I will to check continuity required also, as it is a members rotations will be same as CB is rotated in clockwise direction. The C, the slope at joint C must be clockwise direction and on. That's why this member will rotate in a triangular shape, not in a rectangular shape.
Okay, sir. So before get into the problem, should I draw the deflected shape of the particular beam, sir, like what you have drawn in blue color?
This one or this
The
one.
blue color you have, second one. Should I
This is what
draw?
this is what I love shear for sets. I am drawing in the same diagram. I don't know. Sorry, can you please raise your doubt?
Sir, before get into draw any ILD shape, should I
Okay.
draw the deflected shape of the particular beam like what you have drawn in the blue color?
No, no need. But I'm just telling you these are just verification purpose, whether whatever the things we have done, whether they are right or wrong.
Because now I'm getting confusion that the D should be, D is the free hand. So it may come the zero slope. That's why I'm asking.
D might come.
D might come, C to D might come the zero slope.
Why?
So
Why
this
it
is
will be zero slope?
that is why I'm raising this question. So should I draw the deflected shape for the verification?
No need to draw the shape, but instead you can say that, see, here I'm just writing these conditions. If you can write down, then that might be useful. By looking at the diagram itself, we can say the slope at joint C of connected members will be same. Even this condition might help you.
Okay, okay,
Wait,
okay, sir.
instead of drawing the shape.
If I draw the ILD for right side of the, then it becomes a zero slope, sir. Am I right?
Yeah, it becomes zero slope. Why? Because if I draw right
Okay.
side of C, the diagrams looks like if I place a vertical shear hinge here, then as you can see, this simply tilt upside.
Yeah, okay, sir. Now I
What
understand.
right of C.
So at the junction, the slope should be the same. That is, continuity
Same.
should be there.
Yeah, continuity should be there. As you can see here, even after the deflected shape, the slope will be 0 here. The slope will be original member 0 here. So the condition is automatically satisfied.
So continuity is means the slope should be same
Yeah.
for both the
The
member.
Yeah. If you are talking about a joint, yes, the slope should be
Yes,
same.
sir. Yes,
Until
sir.
and unless there is no hinge there. Obviously, there won't be any hinge if there is a continuous joint, just like here at joint B. Here,
Okay.
there is no requirement that slope should be same. Why? Because as it is a hinge, the slopes can be different.
Hinge is at B, sir. Because of the support is fixed support, do we have the zero slope in between A to B, sir? Or
Yeah.
because of hinge, we are getting zero slope? Because of a fixed support only, we are getting zero
That's
slope,
why
right?
it should be zero slope. If it is
In
not
between A to B. Okay.
if it is a hinge support, then it might not be a horizontal slope. There might be a slope. But if I place a hinge support there at A, then obviously I can say that this is not stable, isn't it? Instead
Yes,
of fixed
sir.
support, if I place a hinge, that is unstable structure. So
Yes,
that's why
sir.
to balance that, I have to add additional support somewhere around here. Then again, the entire diagrams will change, isn't it?
Yes, sir. Okay.
It's all about how we arrange the supports and how we make it for which type of ILD we are drawing.
Okay, okay.
Clear, Ramya, for you? Or Priyadarshini, for you? Any doubts? Ramya,
Yes, sir.
are you okay with these diagrams or do you need any further explanation? Feel free to ask. Don't carry your doubts once again. It seems fine. Then let us go back to ILD for bending moment. We will see application of all these cases with one example or with two examples. The main heart of this ILD is first you should draw it correctly, then only we can able to apply it correctly. So that's why we are practicing so many problems. As setting, hey Vishnu, let me tell you. So at right of C, I can place a vertical shear hinge and then I can move it with unit displacement. As right side part, we are tilting in upward direction. As you can just see at this end, there is nothing to restrain. They can deform in any direction. They can deform in vertical. As it is a free end, they can deform vertical, they can deform horizontally, or they can be rotation can also happen. Just imagine you have cut at one point, and if you try to push it there, how the free end is going to look like. Imagine take a pen and hold it at one end. Take any pen, hold it at one end, and try to push it in upward direction or downward direction, any direction. How do you think it will move? Apply in reality. Take any pen or anything, hold it at one end, try to push it in any direction, upward or downward. How it is gonna deform shape? I think as I can say, this will simply the whole part has moved, might have moved either upward or downward. Am I right?
This is for shear force at right of C. Am I right,
Yes.
sir?
Right of C. Ideally for shear force to the right
So
of
it
C.
will move horizontally. Okay, it will move horizontally. That is the right side part will move horizontally.
No. Why you are saying horizontally? There is no point of horizontal direction here. We are talking about vertical direction, isn't it? I don't exactly understand what you
It
guys.
is the horizontal line. I'm saying about the horizontal line. It will be a horizontal line. Am I right?
The part of the CD
Okay,
will
okay.
simply move. the slope is equal to 0. This itself will simply move either in upward direction or in the downward direction. What if, imagine, in the same case, if there is a support like this, what do you think the deflected shape might be?
Slope
Will it be in the same? Will it be in the same as previous?
No, sir.
Why? Because as a D, imagine this is a joint D. As a D, there is a support. Will it allow any vertical deflections? No. So
No,
that's why if you move this in vertical direction, as it will allow the rotation, the deflected shape might be like this. Why? Because as it is a support, it won't allow any vertical deflection. So you can understand or correlate these two, then you guys might get clarity. Vishnu, what about now? Okay, then let's talk about ILD for bending moment. Let us say, let's consider a simply supported beam and imagine there is a length L, and imagine we want to draw ILD for at any point for bending moment at C. Let us say the lengths will be A and B. Now, if I want to draw ILD for bending moment, what I should do? I should release that force, isn't it? How can I release the bending moment? How can I release the bending moment? By placing a hinge. So wherever you want to draw ILD for bending moment, you have to place a moment hinge there. So if you place a moment hinge, then the bending moment will be equal to 0. And then what you should do? You have to apply an unit rotation. Now, at point C, after placing a hinge, how many members are connected? If I treat it point C differently, if I take the left side part, member CA, and if I look at to the right side, I can talk about CB. As I'm placing a hinge there, what do you think? Slope of CA, can I say slope of CA equal to, can I say slope of CB for a hinge? After placing a hinge at point C, can I say that my slope of CA is equal to slope of CB? Can I? Once again, I'm asking you, now I'm after placing the hinge at C, can I say that the slope of connected members will be same?
Yes, sir.
Yes. We are talking about which type of hinge support. Wherever there is a hinge support, what I'm telling you, wherever there is a hinge, the rotation might be different.
Be different, sir.
They can be different, they may not be equal. If there is no hinge, then only the slope of the connected members will be same. As I am placing the hinge, two members are connected, theta CA and theta CB. As there is a hinge, the slope might not be same. The slope can be different. According to the ILD, after releasing the force, what we have to place or what we have to? We have to apply unit displacement, right? If it is a force, I am saying that it is a unit displacement. Now I am talking about bending moment. If I am talking about bending moment, instead of applying displacement, what I will do? I will apply an unit rotation. Can I say it?
Yes, sir.
First of all, I have released the force at point C by placing a hinge, and then I will apply an unit rotation, and then I will see the deflected shape. Then I can say that that is the ILD for bending moment at that point. Now, just to give you clarity, wherever you want to draw ILD for bending moment, move that point in an upward direction with a magnitude of A, B by L. I will tell you why and I will justify this in a minute. Wherever you want to draw a bending moment, first of all, place a hinge there and then move it the point in upward direction with a magnitude of AB by L. If I move that in upward direction, can you tell me how the deflected shape will be? Will it allow any deflection? Point A, vertical deflection? No. Will it allow any deflection? No. How the deflected shape will be? Like this? Is it right? If I move point C to somewhere, is it the deflected shape or not?
Yes, sir.
Right? Now, what is the amount that I am placing? Let us say this is delta. What is the delta I am applying? That will be equal to AB by L. Now, member CA is rotated in which direction? If I move that to the upward direction, what is the direction of rotation, or what is the rotation of member CA? Can you tell me? What is this direction?
Anti-clockwise.
Anti-clockwise. What is that magnitude? Can you tell me? What is this distance? Delta. What is distance? A. So what about the slope here? Theta CA. Delta by L. That will be equal to how much? What is delta? Sorry, delta by A, right? Here it will be AB by LA. A gets cancelled, then what about the length? B by L. Similarly, what about the slope of CB? Delta. What about the slope? What about the horizontal distance? B. Delta by B. If I solve this, how much I'll get? Delta CA, I am getting it as B by L. Delta theta CB, that I am getting it as delta by B. That will be equal to AB by L by B. BB gets cancelled. A by L, right? What is the slope of member CB? Member CB is deflected in or rotated in clockwise direction. Member CA is rotated in anti-clockwise direction. Now, what about the slope at point C exactly? How can I say, or what is my slope at point C?
0, sir.
How can I say it is 0? There is a slope at CA and there is a slope at BC. How can I say that they are 0?
But exactly at the center, there is no slope, no, sir.
How can, let us say, I'm just drawing the enlarged way. This is the slope of CA and this is the slope of CB and this is the point. Don't we have any slope here? It is not a horizontal line. That means there is a slope. How can I define the slope then? Extend this line. This is what we will call it as a relative slope between these two members. What is this relative slope? If this is theta CA, what about this value?
Theta CA plus theta CB.
So what is the slope at C? Included slope. Theta slope at C, that is nothing but a theta CA plus theta CB. What is the theta CA? B by L plus what is the theta CB? A by L. If you simplify this, how much? A plus B by L. A plus B is nothing but how much? L, total length of the beam, L by L, that will be equal to 1. So how come you are getting slope at C? Are you getting 1 or not?
Yes, sir.
So,
Yes, sir.
instead of doing all these calculations, what you have to do? Just place a hinge at that point and move that point in an upward direction with an amount how much? A, B by L. If you do that, that means indirectly you are saying that my rotation at point C is equal to 1. Understood? Instead of, it will be difficult. Why? Because let's say as two members are connected directly, or at least for the exam point of view, if you want to apply unit rotation, it will take, in between it will take some time to calculate these amounts. So instead of doing that, what you can do, move the point C to an amount AB by L. If you do that, indirectly you are saying that slope at rotation is equal to 1. Is it okay? ILD for bending moment at a point.
Sir.
Now,
Every time it is AB by L, sir.
Yeah, every time it is AB by L. Obviously.
Okay, sir.
A, B. Let us say, if I want to draw ILD for bending moment at A, what you should do according to the procedure? I have to apply. I have to place a here. Now, tell me what is the difference between this case and this case? What is the difference?
Sir, here there won't be any slope at B, sir.
No.
It is a
Where we
free
want to-
end.
No, not about that. Look at point A. Wherever we want to draw, at point A, how many members are connected? At point A, you have only one member, connected member, right? AB. What about in the previous case? Just like here, if you want to draw ILD for bending moment at C, how many members are connected here?
2 members.
The difference here is that at here, if you want to draw ILD for bending moment at A, only one member is connected. So in this case, what you can do? If there is only one member is connected, then what you can do is that simply apply the unit rotation. If I apply the unit rotation, then how it will deflect it like? Apply an unit rotation, how it will deflect? Just like this. Why? Because as it is a fixed support, you have to release only the moment. That means rotation is allowed. Vertical deflection is equal to 0. Horizontal deflection is equal to 0. That means try to rotate with some magnitude. How is this gonna deflect it? Just like this. If this is the length L, so this is what the ILD for bending moment at A. The difference between here and the previous problem is that in the previous case, we are not drawing exactly at the support. As we are not drawing exactly at the support, wherever we want to draw, there two members are connected. As the two members are connected, to apply the unit rotation, first of all, we don't know how much magnitude rotation will be there in member 1 and how much magnitude will be there in member 2. To compensate or to avoid that procedure, what we are doing, we are moving that point to an amount of AB by L. If you move that, the net rotation will be is equal to 1 by adding the rotation of those two members. But if there is only one member is connected, then what you can do? You can directly simply apply a unit rotation there. How you will, just like how you find out the ILD for reaction at A. ILD for reaction at A, what you will just do, simply you will apply unit displacement. Just like the same thing, apply an unit rotation and try to see the deflected shape. Did I make it any sense between this case and previous case? Is there any doubt?
No, sir.
No, sir. Only if two supports are connected, we have to apply that
Yeah.
AB by L procedure. Otherwise, this
Yes. Otherwise, you can simply apply an unit rotation directly. That's it. If not, then shall we solve some
Yes.
problems for ILD for bending moment?
yes, sir.
In this case, what is the ILD for bending moment at A?
Should we apply unit rotation, sir?
Yeah, same thing. Apply and let me tell you. What is the ILD for bending moment at A? How many members are connected here?
One, sir.
One. That means directly you can apply the unit rotation. And can you tell me what is the deflected shape? Take 2 minutes or 3 minutes of time and just try to answer this question, okay? No issues.
Here also the restraints won't change right now, sir.
Yeah.
One member is connected there. So it will be similar to the previous one.
What about at joint B? Slope deflection will be equal to 0 there. In the previous case, it is a free end. That's why deflection is possible. But in the present case, B won't allow any deflection. What about Vishnu? Can you please type it? What about your answer? ILD for bending moment at A.
You didn't realize the shape, the filter shape, sir. Just
Yes.
it will look like the same bus beam.
Yes, and all?
Sir, is it look like the first beam? First beam.
It's look like first.
The first beam. First beam. Bending moment at the C.
Okay, then let it be. And what about Priyadarshini? Doesn't matter, just think about it and tell me whatever your thoughts are. That's fine. These people are wrong. You can tell me. First of all, guys, at what point I'm asking you to draw the bending moment?
At A, sir.
Point A, sir.
What is the support there?
Hinge.
If it is a hinge support, what is the moment?
0.
So it will be 0, sir.
What is the
It
moment at the
was-
hinge support?
0, sir.
0, 0.
Then how? What the load may be, wherever it may be, what moment? It is a hinge support. If it is a hinge support, what is the bending moment? What is the bending
0.
moment of hinge support? 0. Then why the where? How come the ILD will develop at bending moment at A? It is 0. Bending moment is 0. If bending moment is 0, what you can say? It's simply a line. It's not just always I'm telling you, I'm asking you, doesn't mean that you have to always think about the deflected shape. Bending moment at point A. Point A is a hinge support. If it is a hinge support, bending moment is 0. That's it. Have you guys got it?
Yes, sir.
So where the mistake now? Where is the mistake? It's just that why you guys not able to think that at hinge point bending moment is 0? That's why no need to draw anything. Why that point doesn't strike your mind? This is what we have to concentrate at. That in exam, do not think that whatever we know we should apply blindly. No. Understand what they are asking, react according to it. Clear? I just want to tell you that point again. Nothing else. I will ask you one more thing later on. A interesting question I'll give you. I'm just going to the previous cases so that I can tell you the problems. This is fine. Let me give some problems, why waste time. Just like to the previous case, draw the ILD for bending moment at A. ILD for bending moment at A. Bending moment will exist or not, first of all?
Exist, sir, at the point A will exist.
Will exist, why? Because it is a fixed support.
Yes, sir.
Now, please try to now connected 1. Okay?
Yes, sir.
Now, can you please do the needful and let me check? This might be difficult to draw, but let's see whether how you guys will
Sorry,
manage it.
2 meter, 2 meter, 3
Huh?
meter, 2 meter, 4 meter, sir.
3 meter, 2 meter, 4 meter, yes.
Okay.
Bending moment at A. Just try it. Even if you got it right, nobody gonna blame us.
So, like cantilever should be apply unit rotation, right, no, sir?
Just like I can hint you till this position, I should apply, I have to place a hinge there and I have to apply unit rotation. Till this point, I think you guys can be clear. This is 1.
Yes, sir.
After that,
After
Sir,
that,
at B can be zero, sir.
mirror triangle.
Yeah, what happens as it is a roller support? Will it allow any deflection? No, right?
Not allow
Then
deflection.
obviously,
No,
So it's a mirror deflection. Then it will
and what
continue.
about this? The connected member slope should be same. That's why this overhanging part also.
Same upward. Yes, sir.
What about this magnitude? Ordinate?
Ordinate is AB by L.
zero
Right.
at B.
It's not AB by L. Directly I have given you the slope here. It is one connected member. This is 1. And the length is 3 meters. Then what about this ordinate then? Slope is 1. Horizontal distance is 3. What about
3,
simply
sir.
3?
3,
And what
sir.
about the slope here? Vertical ordinate is 3. Length is 2 meters. What about this magnitude?
Opposite by adjacent side. 3 by 2, sir.
3 by 2. Then what about this slope? If this is 3 by 2, what about this slope?
Same.
3 by 2. Then what about this magnitude? Ordinate it is 4 meter into slope 3 by 2.
3
How
by
much it will be?
2 into 4.
3 by 2
6.
into 4.
6,
6,
Sir,
right? Vishnu, previous case means you mean this? Cantilever? Yeah, please, can you tell me? Just like the concept is same, right? Wherever we want to, or whatever the ILD we want to draw, place a or release that force, apply the unit value. If it is a force, apply the unit displacement. If it is a moment, apply the unit rotation. Just like the same thing, I have placed a hinge here. After placing the hinge, I have applied the unit displacement. That's it. And if I draw, what will be the deflected shape? If I rotate it, just like the same thing, take a pen, hold it at one end, try to rotate it. In the previous case, you have lifted it, but in this case, try to rotate it and see how it will deflect. As B is a free end, it can rotate, it can deflect, it can do anything. So it will form a triangular shape. That's how the deflected shape will be. Zero bending moment. You mean at this joint? Joint A? You mean joint A? That what is the support here? The hinge support, right? Directly. Previously, what is the support? It is a fixed support. If it is a fixed support, obviously bending moment will exist. So that's why first we will release and we will apply unit rotation. But here, directly it is a pin support. As it is a pin support, what is the bending moment? 0. That's it. No need to draw anything. Just out of curiosity, I have given you whether you guys will catch up that when as it is a pin support, you can directly say there is no ILD. That's what my intention. Okay, these are the diagrams like ILD for reactions, ILD for bending moment, and ILD for shear forces. A simple one, can I give you?
Please, sir.
There is a point C. Is it a 2 meter from support? Now, can you please draw what is the ILD for shear force at C and bending moment at C? Simply try it.
C is a hinge point, sir.
No, it is not a hinge. It is a point somewhere 2 meter from the A. It is not a hinge. C is not a hinge point.
Sir, shear force at C is right of C or left of C, sir?
What do you think?
Sir, it will just reflect, sir.
It will just who is the right of C or left of C?
Side C.
Can you hear? where we will not define or where we can't able to define the shear force? Wherever there are concentrated forces, wherever there are reactions, isn't it? Is it a reaction developed? Is there any support acting at point C?
No, sir.
Then no, right? That means it's not at right of C, it's not at left of C. Even we can say at C,
Yes, sir.
right or not?
Yes, sir.
Vishnu, what do you mean triangulate right CB portion for what? Shear force or bending moment? Okay, shear force, fine. What about others?
Deflect, sir.
Again, your voice is disturbed. Can you please come again?
Sir, shear force diagram at the C is left side triangle, right side is rectangle. Am I right,
Left
sir?
side triangle, right side like according to Vishnu. This is according to Vishnu, and according to you,
It is a rectangle portion. Right side is rectangle,
and left side is
triangle, sir.
like this.
Yes, sir.
Okay, fine, fine, fine. And Ramya, what about you and Priyadarshini? Ramya CB will just deflect. That's where that means this is Ramya's, this is Andal's, this is Vishnu's. Priyadarshini, you only left with. If you can give your answer, then or you are just trying. Now see, what is the first thing we should do? Let us say that in this case, I have forgot this point. Like what I forgot is that I forgot that I should release the force and I should apply unit displacement. Still, can we solve it? Did I justify my question? Like, let us say you forgot that you have to release that force and you have to apply unit displacement. Then, still, can you solve it or not? We can, right? Just by analytical way. First, you have to consider a force here. You have to find out what is the shear force at C. First, you have to consider at each and every point, and then you have to draw, isn't it?
Yes, sir.
Now, I'm just telling you the basic classical way to do it. Imagine the force here. Force at C. If the force is here, what is the shear force at C? Can you tell me? Which should I should look into? Right side or left side? I need to find shear force at this point. If the load is acting here, what is the shear at this point?
Right side.
1, sir.
If you look into the right side, only one force is acting. What is the sign convention? Right side upward negative, but the force is acting it downward. So what is the shear force?
So,
Positive one.
Positive. Positive, sir.
If load is moved somewhere here, what is the shear force? If this load has moved to here, what
Same,
is the shear
sir.
force? If the load is moved here, what is the shear force?
same magnitude.
Huh?
Same, it will be constant till C, sir.
Till C. If
It will be
once it moved
constant
here,
till C, sir.
yeah. Once it moved to the right side part, what is the shear force at point C? Still, you can look into the right side. How many forces are there
There
if
will
you
be
look into
2
the right
force,
side?
sir.
If you look into the right side, any forces?
0 force.
That means what is the shear force?
No, sir.
If load is in this force, what is the shear force? 0.
0.
If the load is in this portion, what is the shear force? Constant and 1. Then how you gonna draw this diagram? From here to here it is 0. and then from here to here it is 1. Is this diagram okay for you guys? This diagram.
Yes,
So
sir.
Is
generally
this okay?
that shear force means there will be two shape. One is up and one is down. That's why we couldn't think in that way. Okay, sir.
Now, as you can come here in the original diagram, here I am telling you what we have to place. Vertical shear hinge, imagine that I have placed here. What I told you is that if it is a determinate shape, what is the shape of the ILD? If it is a determinate shape, what is the shape of the ILD? Linear or non-linear? Linear, right? Now imagine that if I try to move this in upward direction, let B, as I told you in the previous cases, as there is no support, it can freely move along electrical direction. That's why the part CB simply move in the upward direction. What about in this part, left side part? This is a fixed
It is
support,
fixed,
isn't it?
sir.
Nor it will allow deflection, nor it will allow rotation. Then this part will not be deflected. Why? Because nor it will allow deflection, nor it will allow rotation. What if this is this support? Then the deflection is 0, then the portion might deflect like this. But as it is a fixed support, the slope is also equal to 0. That means this won't deflect anywhere. So the ILD for the shear force is just this rectangular box. Now you can compare these two. Is it okay? Any doubt?
No, sir.
It's just a cantilever problem, right?
Yes, sir.
Any doubt in these two cases, first one and second one? If you have any queries, let me know.
Yes, sir.
Clear? Now, simply again, can you tell me, or can you please draw ILD for bending moment at C quickly? I think you guys will end up correctly in this case. I am expecting so. Even if you are not, that's completely fine. We will discuss it. Point C, 2 meter, 3 meter. Okay. Anyone?
Sir, it is a triangle from A to C.
Triangle from A to C.
A to C
Okay.
and
And
C to D
C to B.
and C to B. Is it a rectangle, sir?
You mean like this?
Yes, sir.
By looking at this diagram, one thing we can say, you know, what is it? At point C, what we are drawing? Bending moment at C, right? ILD for bending moment. Look at joint A. What is the support? Look at the joint A. What is the support there?
Sir,
It
Huh?
has moment.
fixed support, sir.
What is the rotation then?
Zero rotation.
1.
What is the rotation at fixed support?
Zero rotation, sir.
0. If you are drawing in a triangle way, you are getting some slope. That means, is it right or wrong? Is it violating the continuity requirement or not?
Sir, right side is triangle.
As of,
Left side.
as of now, is this right or wrong? This one is right or wrong?
No, sir. This is
Wrong. Why? Because at fixed support, there should not be any rotation. It is a fixed support. It won't allow you. It will kick us with negative marking. That we should not let that happen. Then, what we have discussed, if I play after placing a hinge, what we have discussed in the previous case, we have to move it by unit displacement, isn't it? With a magnitude of AB by L. If I want to move it by upward direction, again come to the support A. If I want to deflect a shape like this, it won't be. Why? Because if I draw inclined way, slope is getting, but what is the support A? Support A won't allow any rotation. That's why this is not the possibility. As there is a support at A, it won't allow the part AC or deflect. That's why the rotation will be simply like this. This magnitude unit rotation equal to 1. As the distance is 3, 3 into 3 equal to 1. Instead, yeah, that's it. And let us justify this case. Where you guys can pause. First problem is that, see the support A. Will it allow any vertical deflection? 0. Will it allow any rotation? No, 0. That means the member AC nor will deflect nor rotate. This will simply in the horizontal only. Then whatever the rotation will be there, that will happen in the part CB only. That is unit rotation. And this is what the deflected shape. Now, can you ask me any queries that you have in this case now? That's it here. I don't think there might be a complex way of this. You guys didn't get it, or you want some more explanation for ILD for bending moment?
Some more examples, sir.
Huh?
Some more examples.
Some more example. In this case, is it okay? At least for CB?
Sir.
Sir, actually, we are confusing and by comparing the normal beam with this bending moment diagram and the ILD bending moment diagram. Sir. The reason is for the case of shear force, we are getting this shape. For ILD and normal bending moment, normal shear force, we are getting the same shape. But obviously, in the ILD, it looked like the opposite nature. The shape is opposite nature. That's why we are getting confusion, sir.
Okay, what can we do? One thing. See, in this topic, as of now for ILD, there are 2 topics left. That is ILD for trusses, and another one is for different type of cases, how we are going to solve it.
Okay.
If you want to, we can do one thing. You guys can practice these diagrams ILDs, and then we can continue it in the next class so that you can get much more clarity instead of continuing it. Can you do that? I think we have discussed all the possible cases for ILDs, for reaction, for hinges, for bending moments.
Yes, sir. We have discussed almost.
So if you want, you guys can go to previous year questions or go to some textbooks, solve some questions, and will you come back? And then we'll complete this ILD in next 2 more classes, this topic.
Okay, sir. We will go through all the topics, then we will write the doubts, all the doubts.
If I feel like if I continuing more, I think it might burden to you and you might get forgot whatever we have discussed. Right now, I think you guys are in the confusion state. You guys have some knowledge, you guys are still in the confusion state, but if you solve more problems, then you guys might clarity. That's what I personally feel. So if you want, we can stop here and solve some problems and forward it to me. I am replying, I am seeing your messages.
Okay.
Ramya sent me and Vishnu also sent me.
Okay.
And I will look into them. I will address to your queries.
Okay.
Or if you want me to continue, I'll continue. Instead, if I want to, if I give some problems, it will be a waste of time. But instead, if you solve it by your own, that will be good. As of now, any doubts? Yeah, that's a good thing. Yeah. So we'll wind up here. At least solve 5 to 6 problems for each case. For shear force 5 to 6, for reaction 5 to 6, for bending moment 5 to 6 problem. And we'll continue and we will wind up this topic in the next class. Fine?
Okay.
Okay, then let's wind up here, guys. And feel free to message me. Feel free to WhatsApp me. I will respond to you in the next class. Even if I don't respond you in WhatsApp, definitely I'll respond you in the class.
Okay, sir. Thank
Okay, then. Thank you.
Sir, when will be the next class? Sir?
I don't know. Let's see. When do you want them?
Oh.
I think actually I'm asking
No, sir,
1
to
hour.
solve the problems, we need at least 2 days.
Yeah, take 2 days. Then we'll continue from Monday then. No issues. Today is I think Thursday. It's in Friday, Saturday. That's fine.
Yes, sir.
That's fine. How many of you are well can have
Okay, sir.
morning? Buddy? Okay, then we'll do one thing. Let's stop here. We'll discuss the things in next class. Solve some problems. Okay. Let's stop here.
Okay, sir.
And feel free to message me. Once again, I'm saying feel free to ask any doubts. Okay, let's stop here. Bye bye.